Alright, had some technical difficulties, so I had to start a new video. And so we're going to start with number 21. Alright, so your parent function for the exponential, you're always going to be at 0, 1. And then when if it's just 3 to the x, if I just think about the parent function being 3 to the x, then when x is 1, y is 3. And then when it's at negative 1, we are at 1/3. Like something like this. So this here is a change in the x values. And so when we see something happening with x, remember you always do the opposite. So instead of multiplying by 2, you are multiplying by 1/2, which is the same as dividing by 2. So when x is 0, I multiply it by 1/2. It's still 0, so I still get 0, 1. So when x is 1, I was at 3, but x is not at 1 anymore because I have to multiply that x value by 1/2, so it moves to here. Right? And then when x was 2, I would have been at 9, which is off the paper, but just so that you get an idea of what's going on. 3, 6, 8, 9. But it's not at 2, 9 anymore because I have to multiply the x values by 1/2, so it moves to right here. So this goes up a whole lot quicker. When I was at negative 1, I was at 1/3, but that negative 1 gets multiplied by 1/2, so I'm now here. And then when I was at negative 2, I was at 1/9, so that gets cut in half, so it's right there. So something like this. Right. Now I've got a log function. Remember that a log is inverse of the exponential. So it looks like this. Okay. So if you want to rewrite it, you can always rewrite a log into exponential if it helps you wrap your mind around what's going on and what your key points are. So this would be 2 to the y power is equal to x. So when y would be 1, x would be 2. When y is negative 1, x would be negative 1/2. Okay, so there's your parent function to show you know what's going on there. Then this is a change in x. We're not changing any of the y's. So the x, we do the opposite. Instead of adding 4, I'm going to subtract 4. So instead of being at 1, 0, I have to subtract 4. So it's 1, 2, 3, 4. I would be here. Then I was at 2, 1, because when y is 1, then x is at 2, right? So that's 2, 1. So instead of being at 2, 1, I have to translate 4 units to the left. So 1, 2, 3, 4, I would be here. And then I was here at 1/2 negative 1, right? So at 1/2 negative 1, but I go to the left 4. 1, 2, 3, 4. I'm here. Also, I have should have done this. Oh, I didn't need to do it on that one. But on this one here, I have an asymptote, and my asymptote is the y-axis, which is the line x equals 0. Since this is a horizontal shift, that shifts with it. So instead of being here, it shifts 1, 2, 3, 4 units to the left. This is my, oops, goodness gracious. Always better. Yours should always look better than what I'm doing up here. Okay. So then when I go to draw it, I got to be careful not to cross that. It should look something like that. Okay. So that's it for your parent functions and your transformations. Let's look at the limit stuff. So remember on here, this is bright in orange, we are ignoring the first part of this. We have not done this yet. That is definitely not on the test. We are just looking at graphs. Okay, so I'm going to use the graph of the function f of x to answer each question. So f of 0. Well, when x is 0, see what I have. when x is 0, I don't have a y value. That's open circle. There's nothing down here. So it does not exist. All right, f of 2, well, when x is 2, y is 0. F of 3, when x is 3, okay, this is open, so it's not 1. This is open, it's not 2, but 3 is there, so when x is 3, y is 3. Okay, so now I'm going to look at limits. I was just evaluating the function. The limit of f of x as x approaches infinity. Okay, so as x approaches infinity, as my x's get bigger and bigger and bigger, I know this looks like it just stops. None of these have arrows on them, but it doesn't, there's not a point there, so we assume, I hate that word, we assume that these keep on going. So as x gets bigger and bigger and bigger, if this continues like this, then your y is getting smaller and smaller and smaller. So as x approaches positive infinity, y is going to approach negative infinity. All right, and so limit of f of x as x approaches negative infinity. All right, so as the x get smaller and smaller and smaller, this is an asymptote, so we assume that it just stays there, and that's right there at 1. So as x gets smaller and smaller and smaller, the y values get closer and closer and closer to 1. Then the limit as x approaches 0 from the right. Okay, so as x approaches 0, but coming from the right-hand side, I'm approaching 0 on the x's, my limit is at 2. When I approach 0 from the left-hand side, x is getting closer and closer to 0, my y is going to get closer and closer and closer to negative infinity. All right, so as x approaches 0 from both sides, so I'm going this way from the right, this way from the left, they don't match. Okay, so since these are different, the limit does not exist. Then the limit as x approaches 3 from the right-hand side, as x is getting closer and closer to 3, the limit is 2. As x approaches 3 from the left-hand side, the limit is 1. And as x approaches 3 in general, since these two don't match, it does not exist. All right, on the back. F of 0. Okay, so when x is 0, y is 0. When x is 2, I don't have a y value because that's an asymptote, so it does not exist. When x is 3, 1, 2, 3, then y is 0. All right, so now limits. The limit as x approaches negative infinity. So my x's just are getting smaller and smaller and smaller. Got this asymptote right here at 1. So this is going to keep getting closer and closer and closer to this. So my y value is approaching 1. All right, so when I am approaching negative 1 from the left-hand side, remember that's what that means, then my y values are approaching infinity. And then as x approaches negative 1 from the right-hand side, the y's approach negative infinity. And again, when I just approach negative 1, these two do not match, so it does not exist. They would have to match in order for that to exist. So limit as x approaches 0. So it's not asking me left and right, but let's just look at what's happening. If I approach 0 from the right-hand side, the limit is 0. If I approach 0 from the left-hand side, the limit is 0. So since I get 0 from the left and right, then the limit as f of x as x approaches 0 is 0. So when we approach 2 from the left-hand side, y is approaching infinity. When I approach 2 from the right-hand side, y is approaching negative infinity. And so when I just approach 2, again, They don't match, so it does not exist. And then the limit of f of x as x approaches infinity, so as the x's get bigger and bigger and bigger, got this asymptote here again at 1. So as x gets bigger and bigger and bigger, y gets closer and closer to 1. Okay, so that is it for your review. Make sure you know what your parent functions look like and understand how to do your transformations. And if you have any questions, you can just text me through Remind. I hope to God nothing on here I messed up on, because I know she should be right, but I had a brain fart. It's really late and I'm really tired, but just let me know if you have any questions. All right, I'll see y'all tomorrow.